Washington State University. Go Cougs!
Hello everyone. In this video, we're going to cover the last lesson of the Python for Data Analytics module, Lesson 7, continuing our discussion on Pandas data frames. So to continue where we left off, let's import Pandas and NumPy into our notebook namespace. Now let's talk about indexing. We've already seen an example of indexing by selecting a column from a data frame, but let's see the different ways we can index a data frame. This table here is adapted from the Pandas website, so if you want to learn more, you're always free to search the Pandas website or any documentation available online. So for example, if the operation we want to perform is to select a column, and we have a column label specified in a variable called col, then we can just index into the df at col. We've already seen an example of this. If we want to select a row by label, then we'll use lock in order to select the row. If we want to select a row by integer location, we'll use ilock to select a row. And in this case, lock should be an integer representing a position in the index. These first three examples will return a series, one-dimensional. We can slice rows with the slice operator, and we can select rows by a Boolean vector. Both of these will select a subset of the data frame, resulting in a data frame. So let's take a look at some code that exercises a few of these operations. Here I have random data is a random ND array of 3x4 dimension, a 3x4 shape, and we're going to construct a data frame with indices ABC and columns col 1 through 4. Let's go ahead and print out this random data frame so we can see what it looks like. So here's our index and here's our column. Now let's say we want to just get row B. We want to get a series named B that represents row B in this data frame randDF. So let's go ahead and print out randDF.lock because we have a label B. And so I print this out, and this gives me this row here as a series. So col 1, negative 0.49. and col 4, 1.608. Let's try indexing by location. So let's do randdf.ilock and let's do 1, and that will in fact give us the same series because row 1 corresponds to label B. Now let's do one last example of row slicing by location. So let's print randDF from 0 to 2. So this is going to give us a data frame where we're going to slice the rows from 0 to 2. 0 is inclusive, 2 is exclusive. So this is going to give us A through B. And here's our data frame here. Now let's move on to talk about how we can combine data frames. There are several ways to do this, and the approach you want to take is going to depend on your data and what you want the end shape or the end data frame to be. I recommend reading the documentation on merging in Pandas so you can see the difference between merging, joining, and concatenating. In this example, I'm going to show you how to concatenate using the concat function in the main Pandas namespace. This example is adapted from the Pandas documentation. So suppose we have 3 data frames that all have the same column labels. This is very important. They all have the same column labels. And we want to combine them into a single data frame using concat. So here's our 3 data frames here, and here's a nice image of these 3 data frames. So here's df1, here's df2, and here's df3. We essentially want to concatenate df2 to the bottom of df1 and df3 to the bottom of df2 to form one big data frame where they all share the same columns, but now we have rows that's going to represent all of the rows in df1, df2, and df3. So let's take a look at how we can do this. So first, let's stack all three of these data frames. So let's have frames be df1, df2, and df3. Now, let's store the result of a call to pd.concat, where we're going to pass in these stacked data frames. And result's going to be a data frame with the same columns as df1, df2, and df3, but it's going to have rows for all of the rows in df1, df2, and df3. So let's print result. So here's our result here, which looks just like our diagram here. So this is df1, this is df2, and this is df3. Now this is kind of a small data frame compared to the data frames we'll be working with in a future module on working with activity and health data. So we don't really need to aggregate or collapse this information in order to see it all in a in a Jupyter notebook. But there are still some good approaches to learn now about how we can view large data frames. So there are three main methods that we can use to view large data frames that really help when working in perhaps a small console window in Spyder, or when working in a notebook such as this notebook, L7. So let's start with describe. So let's print out result.describe. So this is going to give us some summary statistics and information about our data frame. Next, let's use head and tail to view the first couple rows and the last couple rows in our data frame. So let's print out result.head. So by default, this shows the first 5 rows. In fact, by calling help on head, we can see that by default, n is 5. So say I really only wanted to see the first 2 rows, then I could specify n to be 2. Okay. And next, let's do result.tail. Same thing here, let's do the last 2 rows. And there are the last 2 rows of our data frame. Next, let's talk about file I/O with data frames. There are 2 functions or methods in Pandas that make file I/O with series and data frames so easy and so seamless to work with. So say we wanted to write our results data frame to a CSV file, a comma separated value file, so we could use it later. Perhaps it's results of running a machine learning algorithm, and we need to be able to write out several results files to compare different parameters for our models. So in order to do this, we need to first specify the name of the file that we're going to write our data frame to. So I'm going to specify mine to be in a subfolder of my current working directory, which is lessons, called files. So I'm going to say fname gets files. Let's call it 2csv example df.csv and results.2csv, passing in fname. Now, if I navigate to this folder, so current working directory, which is lessons, select files, here is this data file, 2csv example df, and here's what the CSV file looks like. So each row is on its own line, and each value in a row is comma separated. So our first row here is our header, denotes the labels for our columns, and the first value in each row represents the index. If I were to open this up with Microsoft Excel, this is what it would look like. Here are our rows, here are our columns, here's our header, and here's our index. Now, Suppose this is a new execution of our program or a new program, and we want to read in this data frame from file into a data frame object in memory. So there is a function called readCSV where we just specify the file name, and we can go ahead and load that data frame in from memory. So if I do this, I get some strange output actually. So here's my data over here, but here's what's supposed to be my index column, but it's this column called unnamed. In fact, if I print out df.columns, I see there's this column called unnamed 0. And then here's the actual index that Pandas has assigned. Now, if I want to clean this up a little bit, reading the readCSV documentation tells me that, in fact, there are a few keywords I can specify in order to clean this up. So I can specify the index column to be 0. That way, a new index isn't created. And if I look at my columns down here, I see A, B, C, D, which looks good. Now, another keyword I want to show you is called header. So header by default will read in the first line of your input file as the header. So those would be your column names. But in some cases, you may not have a header. You may not have column names and you just want default column names. Then you'll set this to none or to false. So I'm going to wrap up our conversation about pandas by mentioning the panel data frame, or excuse me, the panel object, and then discussing a summary of what we've learned. So there is a third object in the pandas library that I mentioned. We talked about series, data frames, and then there's also panels. So panel is a container like a data frame, but for three-dimensional data. And from what I've been reading online is panel is becoming deprecated in pandas. In fact, hierarchical indexing and some other features of data frames are being used more or supported more in order to replace the same functionality you would get with a panel. So I'm not going to cover them, but if you're interested, I recommend looking them up. They're pretty neat, especially if you can find some visualizations of how they stack data frames with items indexed. It's very neat. So in summary, we've covered a lot of information in this module, Python for Data Analytics, especially on NumPy and Pandas. We've really only scratched the surface. There's a great book out there called Python for Data Analysis by Wes McKinney. Wes McKinney is one of the primary authors of the Pandas library, one of the coders. So if you can get a hold of this book, there are some great examples there, and he goes into detail about several topics that I did not cover in this module. So if we do need something else related to ND array, series, or data frames, we're going to learn them as we go. And in the next module, where we talk about working with activity and health data, we're going to be learning a lot more features of Pandas as needed. So I will see you there.